intro! Ooh, cool. I love these things.
And then...
So surprise, surprise, I'm on a field trip, and I couldn't get you to turn on the whole ride over, and I finally just got it to turn on. But, yeah. Space. That shall be today's theme, is definitely space and awesome space stuff, and I kind of just want to stay here my whole life. How does that sound? Ooh, it's making sound. And look at all, oh, okay, cool. So I can talk to you now without looking like I'm talking to you because we're with a lot of people, including my cousin. He's gonna think I'm weird. So. But yeah, okay, so we're totally in the Goddard Space Center in Maryland, and I don't know how long we're going to be here, but a lot of cool stuff is going to happen, and we're going to be in this little space for tourists for like probably 20 minutes until they know what to do with us, so yeah, let's go explore. Huh? Ooh. There's a ball that you can move with your hand. Ooh, and it's a mouse. Okay. Press the button. Press the... Oh, there we go. Continue. Let's play the game. Oh, wait, this is easy. Okay. Before. After. Oh yeah, I'm on fire. Aw. Okay. What? I'm so confused. Anyway, that was boring.
Taking photographs of the sun or taking measurements of the gases of that. So these rockets are very inexpensive. Fins, you see the wings on them? They're fixed. So they're not steerable. So there's a side wing, we won't want you because the side wing will blow them off course. So they're very cheap. And look how simple they are. You know, the only thing that's big is the nose where you put your experiment package. So they launched them from Mars. This big delta is like the very first one from the 60s. Do you remember when we had the earthquake? Are you from this area?
Yeah.
You remember we had the earthquake log? That rocket was swaying back and forth. We were watching, it was like, oh my god. But those wires held it in place. We were thinking that rocket, probably would fall, but those wires go all the way into the ground. They're buried in the cement, so there's a lot of play in them.
So it's not going anywhere.
That black window, you see the black window straight ahead? Mm-hmm. That's where they fly the Hubble telescope. That's where the day-to-day flying, commanding the Hubble telescope is done from over there. And also communications. All the calls coming from the space station right now, you have the space, well, when the space shuttle was up, all the voice calls coming from the space shuttle astronauts down to Johnson, where they command back and forth. We do the communications voice control. It's like your long-distance AT&T assistants. We get the calls and we send them down our phone lines. If the President of the United States wants to make a call, his White House operator will call us. The President would like to make a call to the astronauts on board the space station. So we just hit 2 buttons, and then actually it's not touch panels now. It's like a speed dial. So we connect anybody with the Russians, with the Japanese, with the Americans. This is main communications. Yes. Hi. That was the best time. When we had all this cool stuff. I mean, it was a cold world. We had all these cool planes and everything. Sean, so I was just in a spaceship.
Sean, would you really just... That was my cousin who said that, of course. But look at all this. Isn't that cool? Sorry that was boring footage of no pictures, but he was talking about cool stuff. Alan, are you playing a game? Wow. Wow.
What happens if I put it in the wrong spot?
They tell you you're stupid? They don't let you do it?
I want to put my piece there. Yeah, there you go.
Good job. Good job. Good job.
Come on, what's next?
Good job.
This one's for you, Alan, over here. This one's for
Space Out. Pretty cute.
Isn't that one a little bit more for Alan?
What has been done? What is ISS? I don't know. He's pretty cute.
Who are the people on board the ISS?
That's boring.
God, it has sound.
Hi. Hey, you owe me because I did all of your homework on the bus for you, so. That's right, I did a senior's AP homework. Oh yeah. It was super easy. This is cool. Oh, this stuff is so fascinating. Isn't it fascinating, Joey?
So I'll pay you back. I won't hook you up with Alan. There you go.
Don't, no. Look at that big thing up there.
I only have like...
Oh, no, you're fine. So yeah, how are you, Joey?
I'm fine.
Isn't this an awesome field trip?
Really? Why are you interviewing me?
Because I'm vlogging and
You're so bored, aren't you?
trying to like keep it quiet.
Are you enjoying your Tumblr?
It's not Tumblr, it's YouTube.
You are on YouTube? I thought you were the one obsessed with Tumblr.
I did Tumblr for like a year, like really hardcore, and then I found other stuff to do with my time.
Go look at all the pretty pictures.
I know, right? Ah, so cool. Do you know what this one's called? Oh wait, hey, you are in Science Olympiad for
Astronomy. It doesn't mean that I'm
astronomy.
supposed to know what those
Yes, you are supposed to know what they are,
I've
so
seen
tell me.
it. I've
Look at all the pretty dots.
I don't know, that could be the Andromeda, the Milky Way.
Today
I
I
don't remember what that
totally-
is. There could be the Orion
Nebula?
or Cat's Eye or Crab Nebula. I think it's Orion, but I really don't know.
It's not Orion, because Orion is
There's
very...
an Orion Nebula.
Orion looks very... This is the eye, isn't it? I don't know. That's Saturn.
I feel like it's higher than most
But like, I'm not gonna lie, don't scoff at me, okay? But I totally put sparkles. I totally put sparkles on my eyes today just because we were gonna be doing something with stars.
Scoff.
Scoff at me? See, there's sparkles on my eyes. Can you see them?
Scoff. Yes, I
Yeah. Isn't it pretty?
can. Scoff.
Ah.
At one time, rather than just being the half that's facing the earth. So cool. Yeah. That's right. Last year, yep. And then the advanced composition school is a
A big bubble in space. Our galactic center. What's that mean? Isn't this cool? Did you see these yet? Astronomers used NASA's great observatories, the Hubble Space Telescope, Spitzer Space Telescope, and Chandra X-ray Observatory, to produce an unprecedented image of the central region of our Milky Way galaxy. The resulting composite image is a blend of infrared light and X-rays, which see through the obscuring dust and reveal the intense activity near the galaxy's core. The core is located within the bright white region to the right and just below the center of the image. That's the core of our galaxy, right there. That is flippin' awesome. Isn't that cool, Mr. Suarez? Isn't that really, really cool? All of these pictures are really, really cool. And look, it's just a big bubble. It's literally a big bubble of gas in space. That is legitimately what that is. It's being shocked by the expanding blast wave of a powerful stellar explosion or supernova. Oh, this one's really cool. Mystic Mountain. The chaotic activity atop a 3 light-year tall, pillar of gas. Wait, so that pillar, all of that, right, is 3 light years tall?
But it's tiny up in the sky.
But it's huge!
Well,
To us it looks tiny, but it's enormous. It's bigger than we could fathom in our minds. Like, it really is. Like, you can't fathom a light year, like, your mind can't comprehend the actual hugeness of it. Did you know that?
it's almost as tall as from here to the next nearest star.
Yeah. Which, not the sun, though.
Yes, next nearest.
Next. So, the really far one. I almost just, like, fell into the women's bathroom. Star birth in 30 Deridas. So these are all little baby stars. Aww. A young massive star cluster nestled in the largest stellar nursery in our galactic neighborhood. The cluster resides in the 30 Doradus Nebula, a turbulent star birth region in the large Magellanic Cloud.
Magellan.
Alan, can you stop, please? I'm trying to show the internet awesome things, and you're just standing there making it cool.
The internet wants to see it, they can come for themselves.
This is so cool, though.
This
Like,
is
I wish I had
free.
my camera because look how his
This whole place
you can only
is
see.
like,
Wait, move. Look,
this
you can
whole
only
pla-
see like. Wait, put like a bunny ear up or something.
For
in the
all you
background.
idiots out
You
there,
can
this
only
place
see,
is
like,
free. You
the-
can come in for
Shut
free,
up.
Alan.
Yeah, you can only see like the what's the word I'm looking for? The
Silhouette.
silhouette. No, only when it's far away though, and it's like a silhouette of awesomeness in front of like a freaking galaxy.
Did you just call Alan awesome?
Well, no, but like other stuff is awesome.
I am awesome.
Okay, stop. I'm trying to tell them what this is. It's a spiral galaxy.
can
Majestic
read
disk of
themselves.
stars and no, you can't. And dust lanes are on display in this view of the spiral galaxy.
Well, if they actually cared,
Those
they could
are just
pause
big
it.
lanes of dust.
Can I show them other? Oh, is that one of those cool videos?
Yeah. Yeah, I have a cool video thing. That's right. I have to point out that an astrophysicist just called my flip camera cool. I win at life.
Better.
That is a lot better.
Yes, a lot more using natural history.
Here, let's move in so everybody else can see.
So speed it up. This is the Earth. This is the weather on the last 31 days. So we'll take it up to today, and the colours you see here represent clouds and everything. Precipitation. So actually, I'm so bad.
Is he a storm heading towards Pennsylvania there from
Oh,
a
jeez.
couple weeks ago?
No kidding.
No, go back. Oh. I'm sorry, I can use a Wii. So, Wii.
It's seriously controlled by a Wii. He's not kidding.
That's a
He's using a Wii remote to control this thing. I wish I was kidding.
he's using.
That is so cool.
Woo! I can tell you oh, that's making me dizzy. I'm sorry. Oh, that's where I'm from. I'm from England. And there's okay, Philly over here. So you can go this way. So you see the clouds here? The clouds represent the height of the clouds. So the top clouds are blue, fuchsia's at mid-level, and white is the bottom of the clouds. And it also tells you how much precipitation there's in the
Our
clouds.
data we're trying to get on the 3D sun, we're trying to get up on this one.
So I'm getting to the sun right now. So this is called Science in the Sphere. I'm not supposed to touch it, but I always do. I make a mark on it. It's carbon fiber came in two halves that we glued together. We use spackling compound when you make a hole in the wall. We use that compound to smooth the two halves together. Painted with household paint, matte paint, because you don't want to gloss paint, otherwise reflect a lot of the light off the projectors. And then we hung it from the ceiling. There's 3 high tensile steel wires from the ceiling. And the images are coming not from the inside, from the 4 projectors on the outside. 1, 2, 3, 4. You see, when I wave my hand, you see, hello. And then over here, that projector takes over. So anybody who moves a projector, boy, we get them out far. Because you can't hit, if you hit the projector, it's going to move everything out of alignment. So we have to have it perfectly aligned. And it's all operated by that PC that's in that cabinet. Red Hat Linux is the operating system that we use. Linux is so... Do you guys know about Linux?
Yep.
That's what we use. Red Hat is the best software. So let me show you some images of the sun.
Oh, the sun. We're going to see the sun. Are you ready? He's going to change it. This is cool, though, isn't it?
They have a bust of Goddard out there. It's
I think
with Red Hat.
he's from South Africa.
I did.
Maybe?
So they use, what they do is, that this is in a certain wavelength. I think this is probably...
Autobahn.
What?
They don't tend to be green, but
The wavelength.
Yeah, it's one of the ultraviolet, but I think it's the calcium.
Oh, that's so cool.
Oh, so that's just flare going off. So the standard
flare
thing
going
with
off
images that are outside
creates, like,
the
static and stuff.
human range of vision is that you take a color and, display it in a color that human eyes can see. So this is ultraviolet. Your eyes can't see it, but they show it in green. And by standardizing some of the colors, no matter which cameras are taking the pictures of the sun, they show this line of ultraviolet always in green, so that people get used to seeing, sort of, oh, yeah, this is that wavelength. So, this is an ultraviolet regions or sunspots in active regions. The sun is really interesting because it's a magnetic star. It's got a very strong magnetic field that gets all twisted up because the sun doesn't rotate the way the Earth does. The Earth rotates as a solid body, and the sun, which is a plasma, it's more like a liquid than a solid. And I don't know if you've ever seen in museums the little ball of liquid that you can spin and then you stop and all sorts of little whirlpools go up. So the sun sort of does that, and the poles are actually rotating slower than the equator does. And the magnetic field then gets all twisted up. I like to think of it as a ball of rubber bands. And this, what's called differential rotation, twists up those rubber bands, and eventually you build up enough tension that it's got to be released somehow. And the way it's released is in these sunspots, active regions, in solar flares. So solar flares are sort of like the rubber band snapping very quickly. And you'll see things happening. And so each of these lines that you see is a line of magnetic field. That's a solar flare. And there you can see the energetic particles hitting the camera 93 million miles away. So those are solar energetic particles bombarding the camera out in space. So
Cool.
have you ever done the experiment where you've taken a magnet and iron filings and looked at the magnetic field lines? You know, and you can see the shape of the magnetic field? That's exactly what you're seeing here. So these are little magnetic loops on the sun, and they're caused by hot plasma streaming along the magnetic field lines. So we're learning a lot more about the sun now. We actually have stereo spacecraft. So if you were standing at the Earth, we have two spacecraft now that are more than 90 degrees in front and behind the Earth in basically the same sort of orbit. And we can now, for the first time, see the entire sun the way you're seeing it here. See the sun at one time, back side as well as the front side. And
This is stereo.
Okay, so this is-
Let me try this one. This is full of, well, let's see. That's stereo. But on the back side, I don't see anything. Let's see if that gets scrolled down. Move this. Is it doing it?
Oh yeah, so there's
This is kind of flat.
this is stereo from before we reached 180 degrees apart, because it's still got a gap. But
It's filling up.
okay, so
And that's probably where the head goes. Is it the two stereos? Can they still see the same view? Can they see behind and in front?
well, they're now more than 180 degrees
Yeah.
apart. So in combination with SOHO and SDO, you get the entire sun.
Black out the areas of the United States that become
Ontario, the big Ontario
big
blackout.
Ontario. Thank you. Yeah.
Yes,
It's
1987.
Due to blackout.
Yeah. So
that's
this was actually due to a solar flare, where a solar flare took out the electric power grid and caused an enormous blackout in North America.
How did it do that?
Well, see, the solar flare actually impacts on the magnetic field, and a moving magnetic field generates currents in long wires. And the longest wires around are the power grid. So the power companies tend to run these room-sized transformers at nearly their full capacity, because that's the economical thing to do. So they're running at 99.5% of the maximum current they can take through them. And when the Earth's magnetic field moved and added some extra current in, a couple of these room-sized transformers literally blew up from the extra current.
Yeah, find it for you.
Is a pretty new spacecraft, and it's really cool, because you talk about high def.
This is called solar wind.
Because it's on the spinning, it sort of looks like one of these garden sprinklers. It sort of sends out the solar wind in all directions, but that, as the sun spins, the faster wind moves like a sprinkler and actually builds up, catches up to the solar wind and forms shocks or co-locating branch regions. And that's another part of space weather.
This is called a clean room, and there's absolutely no dust in there. It's kind of scary.
On this wall.
Look, that's going to be in space.
So if you can picture a wall 3 times the size, because we need 18 segments.
And that's going to be in space. And these are just
So
testing
that's
equipment
the mirror
things.
size.
Those are all
And
filters.
this, of course, is what
The
it
air in
looks
there is
like.
about 1,000 times
So
cleaner
all
than a
the-
hospital.
The solar
There's
panels
holes in
will
all
be
that wall,
here
and the air goes back
underneath.
out within 90 seconds
And
of
this is
entering.
going to be
It's
positioned
really cool.
1,000,000 miles out in space, farther out than the Earth, okay, from the sun, so on the other side of the sun. So 94 million miles out at Lagrange 2 will be where the James Webb will be. And
telescope.
the Earth, it will be traveling with the Earth. So the Earth will act as a shield to the sun. And there's all get here, which is not going to be, I guess, for probably till 2014. So they'll start coming in. They'll start coming in the end of this year, and the instruments will start coming in at the end of this year. But this structure this morning, it might be down there. So that's fine.
Will they actually assemble the whole setup?
An actual prototype of a
Okay,
mirror
so,
that would be like the ones on the new telescope that we've been talking about.
Actually,
And it's beryllium and
the
gold.
final testing
Isn't that
will be in Houston, in Texas. You know, that little picture I kicker.
Is that the inside of that building?
Yes. So this
Vibration
is what is
tables.
inside of that building. Right.
Cool. Super secret special room. Cell phones are off.
Scroll along. Don't go too far. So guys, just turn your cell phones off.
Don't drop it.
See, I'm gonna drop you.
Messages, I guess.
JK. Why would I ever do that?
Yeah, well, you can tell.
You guys want to go to space? I'll just leave you recording, and you'll have infinite recording time and infinite battery, and you'll go to space.
Quiet on this end here.
Yeah. Nobody's really around.
I guess you think you more like
I
that.
don't see like anything interesting happening.
As you can see, we have portable clean rooms up here. We've got two other.
That's another clean room right there.
One of the oldest buildings,
So those are thermal vacuum chambers. So they take all the air out and then they make it really, really hot and really, really cold to make sure it can, what am I saying? To make it to test and see if it can, the equipment can withstand the vacuum chambers and the hot and cold temperatures of space. Bleh, talking. Okay, that's legitimately 5 computers and 4 keyboards and like, I don't know, 4 mouses I think. I'm so confused. He's doing some hardcore work. Yeah, it's loading. It's totally loading. And it totally is just like our school computers, which sucks. Oh, I just took the camera off of it. But look how cool this stuff is.
They get it for free. It's probably like.
Results were out on their website for a long time. That was 3 years ago now, so I don't think it's still out there.
No.
That's an actual satellite. Oh, you can like hardly see it beneath the covering, but it's a satellite. And this thing is really cool. It's a big vacuum and heat chamber, and it's enormous. Doesn't it just look like it's from space? And it's snowing. Isn't that pretty? It looks a lot prettier in real life. You can't see it too well on the camera. But yeah, we're home. Hey guys, we're back. So today Penelope was being the most, I don't want to say misbehaved flip cam ever, but that is the only phrase I want to use to describe her. Honestly, so much angst. Let me fix the lighting. Better? Okay. So I tried to turn the camera on so many times and missed a couple things actually, and it's to the point where it needs to stop. I need a new flip cam. Not that it's anybody's business, but so far I've made about $50 at work, and I'm thinking, you know, I'm gonna make another 50 and then I'm gonna spend half of it on the flip cam. I really want to save money, and I really want to buy things, but until I get more steady hours and I'm actually making like a decent amount of money a week, I can't afford to buy a flip cam just yet. So I'm gonna wait until I get another 50 and then I'll have $100 of spending cash. I don't think any of you understand, I'm actually literally broke. I have no money. I use my parents' money. Perk of being an only child sucks though, because if you ever need anything you have to get money from them and they can say no. So I'm really glad I have this job. I just need to make more money before I can actually do anything, which is fine. I'm only 16, so it's not a big deal, right? So anyway, but today was a lot of fun anyway, and we went to the NASA thing and it was awesome and stuff. That was all that happened today, but it was really great. I'm really tired, so I'm gonna go to bed.
and I hope you all have a fantastic day. Premature wink. Good night. Off button.